Good morning, everyone. This is K.Bharat Chandra from ECE department, and today I'm going to discuss about the topic neural networks used to recognize the objects in digital image processing. And here, these are the contents in this PPT I'm gonna discuss about, and those are introduction, perceptron for two pattern classes, training algorithm, multi-layer feed-forward neural networks, and these are the topics. And introduction to neural networks. Neural networks are works like uh, the neurons that are interconnected in the human brains. And these networks consist of layers of neurons, and each neuron takes an input and performs some of the operations, and then passes the output to the next layer of the neurons as the input. The patterns of the known pattern classes are used to estimate the parameters known as training patterns. These patterns are called training patterns, and such patterns and set of such patterns are called training set. The process of using these training sets to obtain decision function is called learning or training. The neural networks uses the method in a way that yields the required decision function directly by training. And perceptron of two pattern classes. The perceptron learns a linear decision function that divides two linearly separable training set of two pattern classes. Let us consider those two pattern classes as A1 and A2, and here the pattern vectors are given as inputs, and these are the weights, and these weights are multiplied with the pattern vectors, and uh, those products are added to each other, and this gives the decision function, and this decision function gives to the activation element, and it gives output as plus minus plus 1 or minus 1 based on the decision function behavior. Here we can see the decision function is given as d of x is equal to summation of weights, product of the weights and the inputs plus the omega naught. And if the decision function d of x is greater than 0, the activation element causes the output as plus 1, indicating the pattern x belongs to the pattern class A1. And when dx less than 0, then pattern x belongs to the pattern class A2. The training algorithm for the training sets of linearly separable classes as follows. For two training sets of pattern vectors belonging to the pattern classes A1 and A2 respectively, and the W of 1 represents initial vector. This may be chosen arbitrarily, and here C also chosen arbitrarily, and after k iterations, if y of k belongs to a of 1 pattern class, and w of k y of k less than or equal to 0, then w of k plus 1 is equal to w of k plus c into y of k. Otherwise the w of k plus 1 is equal to w of k. In a similar way, if y of k belongs to a2 pattern class, and w transpose of k into y of k greater than or equal to 0, then wk plus 1 is equal to w of k minus c y of k. Otherwise, it will be the w of k plus 1 will be w of k. And multi-layer feed-forward neural networks. And this is the schematic diagram of multi-layer feed-forward neural networks. And here, these neurons, this layer of neuron are connected to the next layer of the neuron. And here, the inputs are given to these neurons, and the outputs of these neurons will be given to the inputs of the next layer of the neurons. Here this layer is called input layers, and this layer is called output layers, and the middle ones are known as hidden layers. These neural networks consist of layers of structurally identical computing nodes. Those are structurally identical Nodes are called neurons, arranged so that the output of every neuron in one layer is the input of the every neuron in the next layer. The network recognizes a pattern vector X as belonging to the class AI if the ith output of the network is high while all other inputs are low. Neuron has the same from the perception model, with the exception that the hard limiting activation function has been replaced by soft limiting sigmoid function. Thank you.